1/5 of the land surface of the Earth is covered by deserts, which is almost 50 million square kilometers. To many, the word desert evokes images of vast seas of shifting sands. But in reality, sand dunes cover only 1/10 of the land surface of arid regions. Even in the case of Sahara, the largest desert in the world, sand dunes cover only 1/3 of the land area. Thus, major portions of the deserts may be mountainous, rocky, or may comprise of vast stretches of salt flats. So what qualifies as a desert? According to experts, any area of land receiving less than 25 centimeters of rainfall in a year is classified as a desert. Thus, deserts are mainly the creation of the global patterns of the climate. The yellow areas in this world map show the semi-arid and arid regions. And if we look carefully, we will notice that the world deserts are all located between 15 and 30 degrees parallels of latitude on both sides of the equator. The Sahara Desert, the world's largest desert, is in North Africa. The Kalahari Desert is also located in Africa, and it is in the southern end of the continent. The Thar, the Great Indian Desert, is spread out over western India and Pakistan. The desert belt continues further into the Middle East, and finally, the Great Australian Desert. All these deserts are hot and subtropical. Deserts like the Great Basin and the Mojave Desert of USA, the Patagonian Desert in South America, and the high-altitude deserts of Central Asia are all sheltered by mountain ranges and vast continental areas. These are classified as rain shadow deserts. The Atacama Desert in Chile in South America is a coastal desert that receives no rainfall as it is influenced by cold coastal currents. It is one would imagine the desert to be Flash floods are quite common here, and when they occur, the mud and silt-laden water scours the ground, carrying before it huge amounts of mud and silt. High-velocity winds with speeds of over 100 kilometers an hour often blow across the desert. Since there is little vegetation or moisture to bind the loose surface materials, the effects of wind erosion are almost unrestrained. These strong desert winds lift loose materials from the desert floor and blow these along. This process is known as deflation. Depending on the size of the material, unconsolidated sand and pebbles may be carried in the air or rolled along the ground. Fine dust and sand may be carried for miles before being deposited, sometimes even beyond the margins of the desert and across continents. erosive action of wind on flat surfaces is also very interesting. Deflation, which is the removal of surface material, results in the lowering of the land surfaces and the formation of a depression, which is called a deflation hollow. The Kantara Depression in the Sahara Desert is a depression hollow and is over 100 meters below sea level. When wind-borne particles collide against each other, they wear each other away and their size is gradually reduced and the grains get fairly rounded like tiny millet seeds. This process is called attrition. When the wind hurls sand particles against rocks, it causes the abrasion of the rock surfaces. The rocks get scratched, polished, and are eventually worn down. Abrasion is the greatest at or near the base of the rocks, and it is here that the maximum wind erosive action takes place. Rock pedestal or mushroom rocks are formed by the sandblasting effect of the wind against any projecting rock mass. The constant sandblasting wears the softer layers of the rock, producing irregular, fantastic, and often grotesque-looking rock structures called rock pillars. Such rock pillars are further eroded near their bases, where friction is the greatest. This process of undercutting produces rocks of mushroom shape, and the structures are called mushroom rock. Small rock ridges called yardangs are also produced by the action of wind. Hamadas, or desert platforms, are another feature found in the deserts. These are large, polished, flat rock bed surfaces, exposed by deflation and rubbed smooth by erosion. They are often laid like a fine mosaic on the desert floor. Sustained wind action polishes these rocks to greater smoothness. In semi-arid materials are shifted according to their coarseness. The heavier sand particles remain on the floor of the desert as dunes and other depositional forms. These seas of sand, however, are rarely static. Their flow and migration depends on several factors, like the size of the particles, the direction and velocity of the wind, and the location and nature of the surface over which these particles are found. The presence or absence of water and the natural vegetation is also a controlling factor. Sand is moved and deposited by wind in the form of ripples, dunes, sand ridges, and shoots of loess. Ripples form transversely to the wind direction. Some are aerodynamic ripples, created by regular patterns of wind turbulences. The others are ballistic ripples, formed by the bouncing or saltation of most wind-blown sand. These moving grains of sand form sand dunes. Sand dunes come in a wide range of shapes, sizes and patterns. The classic crescent-shaped Barkhan sand dune is only found on hard desert surfaces that have little or no sand covering. Barkhans are initiated by a chance accumulation of sand at an obstacle, such as a patch of grass or a heap of stones. The windward side is convex. and gently sloping, while the leeward side, being sheltered, is concave and steep. They occur transversely to the direction of the wind, so that their horns thin out and become lower in the direction of the wind due to the reduced frictional retardation on the wings along the edges. The crest of the sand dunes moves forward as more sand is driven up on the windward side, and on reaching the crest slips down the leeward side so that the dune advances. The rate of advance varies from 5 meters a year for high dunes measuring 30 meters to 20 meters for smaller dunes, which may be only 3 to 5 meters high. Dunes may run parallel to the wind direction for hundreds of kilometers in some cases. These longitudinal dunes are called seefs. The crest line of the seefs rises and falls in alternate peaks and saddles in a the In fact, 250 years ago, over 300 of the Bishnois gave up their lives protecting their trees. Their homelands teem with the diverse